So I'm going to go through and explain how we predict charge for certain ions. And what I'm going to do, the way I'm going to do this is by showing you with valence electrons and shorthand electron configuration. So explaining it kind of in two different ways at the same time. What I'm going to do though is I'm going to show you using I'll say 3 different elements. We're going to look at beryllium, boron, and carbon to understand why they have the charges that they do, and then we can use valence electrons to understand it in a different way, and then I'll even show you a cool pattern so you don't even have to do it that way. So I'm going to write out the electron configuration for beryllium. So all it is 1s2 and 2s2. Now, the whole point of life for elements, if they did have a life, their whole goal is to become noble, to become one of these beautiful noble gases. And the reason why is that in chemistry, everything happens because there's this desire to be stable. And noble gases are the most stable elements in all the periodic table. And so it is the goal of any element to have the same electron configuration as another noble gas. So, for example, beryllium, right now it's 1s2, 2s2. So it could lose 2 electrons, so it could lose this one and then lose one more to become helium. Or it could gain 6 valence electrons. So it could gain, you have to skip over 1, 2, 3, 4, 5, 6. Now, just number-wise, losing 2 valence electrons is easier than gaining 6. So what beryllium's going to do is it's going to lose 2 valence electrons. So what happens is this 1s2, 2s2 becomes, if I have beryllium 2+, I've lost 2 electrons, so it's just going to become 1s2. And that's it. So I got rid of the 2s2 because I lost 2 valence electrons. Okay? Now if we consider boron, for example, so now I'm dealing with boron. The electron configuration of boron is 1s2, 2s2, 2p1. Now, boron has a couple of choices. It could gain 5 valence electrons, so gain 1, 2, 3, 4, 5 to become neon, or it could lose 3, so it could lose 1, 2, 3. So, since losing 3 is easier than gaining 5, boron will lose 3 electrons to become boron with a +3 charge, and its electron configuration will now be 1s2, and that's it, because we got rid of this electron and those 2 electrons. Okay? Now I'm actually going to skip carbon and I'm going to go to fluorine. And if we write out the electron configuration for fluorine, you would get 1s2, 2s2, and then 2p5. Now, if you think about it, in order for fluorine to become a noble gas, it could either gain 1 electron to become neon, or it would have to lose 1, 2, 3, 4, skip, 5, 6, 7 valence electrons. So it would rather gain 1. So F is going to have a -1 charge by gaining 1 electron, and its electron configuration will be 1s2, 2s2, 2p6. Now it has the electron configuration of a noble gas, and it's very happy. So, as far as charges are concerned, what you might notice is that the number of valence electrons will either be 8 all the way across. So for example, fluorine had 7 valence electrons, and I'm going to rewrite this up here. This is 1 valence electron, 2, we got this from the other video, 3, 4, 5, 6, 7, and then our noble gas has the 8. It's called an octet. That's the ultimate goal, to have an octet. So fluorine can either lose 7, so if you lose 7, you end up back at this octet. So a good way of thinking about it, if you're just doing it quickly in your head, Elements either want 8 valence electrons or no valence electrons, meaning fluorine can either gain 1 to get 8, or it can lose 7 to go back to this 8, or if you just want to think about it in your head, have 0 valence electrons. So it's going to be easier for this to gain 1, so it's going to have a -1 charge. Okay. For 6, it can either gain 2 to have 8, or it can lose 6 to have 0 or get back to this perfect octet. So it would rather gain 2, so -2 because electrons have a negative charge. For 5, it can gain 3 to be 8, or it can lose 5 to have 0 valence electrons, so therefore it's going to be -3. For 4, it can either gain 4 or lose 4, so it's going to be plus or -4. For 3, it can either gain 5 valence electrons to be 8 or lose 3 to be 0. So it would rather lose 3 to be 0, so it's going to have a +3 charge. Here, it can either gain 6 to be 8 or lose 2 to be 0, so it's going to gain 2. Sorry, it's going to lose 2 to be +2. My brain. Here, it can either gain 7 to become 8, or it can lose 1 to become 0, so it's going to want to lose 1, so it'll be a +1 charge. So the funky thing with this is that if we're losing electrons, we end up with a positive charge, but if we gain electrons, we end up having a negative charge. So that's one thing to be careful about. The cool thing about noble gases, the charge of noble gases is always 0, because it doesn't want to gain or lose any electrons. And that's it.